Hello friends, I am Om Prakash Samantrai, Assistant Professor in CSC. We are discussing entity relationship model in database management systems. This video is a continuation of my previous video where we have discussed what is entity, entity types, entity sets, and different types of attributes. Now in this video we'll discuss the constraints on the relationship sets. Relationship means the association among entity sets, or how the entity sets are related to each other, or how they are correlated to each other, how they depend on each other. That is defined by the relationship set, right? So there are two constraints on the relationship set. One is called as your mapping cardinality, another is your participation constraint. First we'll discuss what is a mapping cardinality, then we'll go for participation constraints. So in mapping cardinality, the number of times an entity of an entity set participates in the relationship set, that is known as your cardinality. Or how many number of times an entity in one entity set is participating in the relationship set. Let's say department and employee. These are the two entity sets. There is one relationship set exists between these two, right? Or employees works for department. So works for is a relationship set. So how many number of times the entities in department is participating in the works for, or how many number of times the entities in the employee entity set is participating in the works for relationship set, that is called as your cardinality. So this mapping cardinality is of four types: one to one, one to many, many to one, many to many. You can represent this one to one, one to many, many to one, many to many, these mapping cardinalities diagrammatically. You can easily understand if you look at the diagram below. The bottom diagram, the second one, you can see here this is one entity set, M1, M2, M3. These are the entities in that entity set. In the rightmost, F1, F2, F3, these are another entity sets, and the middle one represents the relationship set R1, R2, R3. Now M1 participating once, M2 is participating only once, M3 is participating only once. Similarly, F1, F2, F3 of the second entity set is also participating only once in the relationship set. From both the sides, the participation is only once. That's why this cardinality is called as one to one. So you can take one example of manager manages a department. If there is a constraint called one manager manages only one department, in that case you can say it is one to one mapping cardinality. One to many, when only one entity or each entity of one entity set participates only once, but each entity of another entity set is participating more than once in the relationship set, then that is called as one to many. So diagrammatically you can represent like this, or uh, you can see the second diagram here, that is A and B. These are the two entity sets. A is related to B1 and B2, A2 is related to B3 and B4, A3 is related to B5. That is one to many. If you see the first diagram, that is one to one. Every entity in A is related to one entity in B, that is one to one. But in the second diagram, this is one to many. Or you can represent this diagram as shown in the in the previous slide. In this way also you can represent that diagram, right? So many employees are working in one department. From the department side, if you read, one department has many employees. From the department side, the participation is only once, but from the employee side, the participation is many. That's why the relationship is one to many, or the mapping cardinality is one to many. Many to one, that is just the opposite of one to many. Many employees are working in one department, that is, you can say it's many to one. Many students has enrolled in one course. Example is shown here. See, n is written here to represent many, 1 is written here to represent 1. And you can see here, you can also use asterisk symbol to represent many, right? So asterisk symbol and 1 can be written here to represent many to 1. So many to 1 is simply the opposite of 1 to many. You can see here, from S1 to R1 the participation is only 1, but from the other side, C1 and C3, they are participating many times. Some of the entities are participating many times. C3 here has relation with R2 and R3 as well as with R4. That's why this is many to 1, from C to S. From the side C, if you read, that is many to 1. From the side S, if you read, that is 1 to many. Similarly, many to many, when both the sides they are participating more than once, then that is called as many to many. When entities in all the entity sets can take part more than once in the relationship set, then that is called as many to many. And you can see the example, many students enrolled in many courses. This is also one of the possibilities. If there is a provision, many students can enroll in many courses, then you can represent them like this. You can write m here and n here. They represent many to many relationship. Here m and n are written because the number of entities of student who are participating in enrolled in need not be same as the number of entities of course who are participated in the relationship set. That's why two different variables are used here to represent the many to many relationship set. You can also represent that using this diagram, right? We have already seen this in a unary relationship set, that is also known as your recursive relationship set. When only one entity set is participating in the relationship set, that is called as unary or recursive relationship set. In this case, you can see one employee who is acting as a simply one employee who is reporting to the supervisor. Subordinate reports to the supervisor. Both of them belong to the same employee entity set, but they have different roles. So subordinate and supervisor, they are called as these are known as the role of the employee. The function of any entity which it plays in the relationship set is called the entity's role. So in this, some of the employee act as a subordinate, some of the employee act as supervisor. So the same entity set employee is participating in the relationship set. This is called as your recursive relationship set. Now you can see this is also one kind of type of the relationship set. We have already seen this in our previous slides. It's a kind of ternary relationship where three different entity sets are participating in the relationship set. You can also represent like this. We are discussing the constraints of the relationship set. The first one we have discussed was mapping cardinality, and the second one is your participation constraint. Participation constraint is of two types: total participation and partial participation. If every entity in the entity set is participated in the relationship set, that is known as your total participation. If only some of the entities in the entity set are participated in the relationship set, then that is known as your partial participation. You can see in the example, there are double lines between employees and works in, and double line between department and works in. The double line denotes total participation. Single line denotes partial participation, right? And total participation means all the employees in the employee entity set are participating at least once. Similarly, all the departments entities in the department entity set are participating at least once in the relationship set. Then we can say that is total participation. Another example, there is a relationship between customer and loan. If there is a customer, it is not necessarily true that the customer must have a loan. But if there is a loan, then always it is true that the loan must belong to a particular customer. So that's why from the loan side, the participation is always total, because if there is a loan, there must be a associated customer. If there is a customer, it is not necessarily true, it is not mandatory that the customer must have a loan. That's why the participation is partial here. Partial participations are represented using single lines, and total participations are represented using double lines. Now in the next video, we'll see what are the different types of entities, and with that we'll discuss one example how to construct the ER diagram. Thank you very much.